So hello everyone and welcome back to another video. This is gonna be the sixth video of our channel Full On Coding. Today we are discussing the DSA topics of linked list, stack implementation using linked list, queue implementation using linked list, and recursion. So stay until the end to understand each and every topic covered in it and have a proper grasp understanding of it, the topics of all mentioned here. So yeah, stay until the end to understand each and every topic. So starting with linked list. What is a linked list, right? We have studied about arrays. Now what is a linked list? It is a type of array list only, but the retrieval process of this particular data structure, that is linked list, is in the pair of head and the value. That is the value and the address pair, or you can say the address and the particular value. So if you are starting from address 100, then you would have some value, like at 100 you have the first value of 1, and into the next address which you get from 1 to 2, the value changes from 1 to 2, but the address goes from 100 to 104 because it is an integer data type. So 4 bits will be there in the used in the compiler, so 4 bits will be taken and you would give from 1 to 2. So yeah, that's right, that's important. So done. So this is basically a linked list where it is containing a value and an address, and the address is pointing to the next node. Here nodes comes into play, where we make a structure node and it has two part, that is value part and address part. So this is all about linked list. Now if we come to the starting part of this particular lecture, we are getting to know about 5 numbers which we are wanting to store an array and how they are stored. First of all, we are talking about the array only, then we will go to linked list. I just gave you a brief about the linked list, on what is linked list, what is the data type. It is also a contiguous memory allocation, but we are connected by nodes, and nodes can be retrieved properly. So here time complexity is changed basically in the array, and node value pair is there. So here array is given 10, 20, 30, 40. Now what is the address? 4 bits difference, as it is an integer value, it will take in the 4 bits of a compiler. So 4 difference, value we have taken this, and your index will be 0, 1, 2, 0 to 4, as there are 5 values. Done. Here data is stored is a contiguous memory. How address is calculated? This is the very famous formula. The first class which you will do of DSA would help you know to get the formula of a particular element in an array. Base address, that is the address in the starting, that is 1000, where here this 1000 only, right? So 1000 plus the index we want to know. Suppose we want to find the for 2, so a of 2 will be equal to 1000 plus the index, that is 2, second index, and into the size, that is 4. So what will be the base address? It will be 1000 plus 8, that is 1008. Here it is given only. So you will get the value of 1008, that is the answer only, and that you will get in the list also. So here you have calculated this using this particular formula only, and here the first source code comes into play. Now we are given a particular C code. Here we are discussing array, we are taking a loop, for loop, we are printing the address. Now how to print the address? Using %p and using the showcase of and of a of I. And gives the address. Yeah, we have seen this in arrays and pointers also, so it is very easy for you to understand, right? %p will give the address. So first element, like 10's address will be taken, and then your first, that is the a plus I, that is if it would be 0, it would be a of 1, right? So here we will get the value. So is this thing we are getting the value, and note there is a 4 difference only, because we are storing integer data type, it accommodates 4 bits memory in the compiler. Yeah, suppose we want to store records of 100 students in class, so we particularly don't need to give the value like name this, roll number this, subject this. No, we can make a particular structure about it, right? We can make a particular table, right, which have all the values of attributes like roll number, name, address, particular student title or student roll number, student phone number, right? Anything. So here we have roll, name, and marks. We have 3 attributes in total. Now what if we don't get 2800 bytes continuously? Because here roll number will store 4, here it will store 20, and float marks will store again 4. So here are 28 bits we require. Now for 100 students it would definitely be equal to what? It will be equal to 2800 bits. So it is very important for you to understand, as these are 2800 bits required. So this particular problem will be solved by linked list. See how. Instead of sorting 10 students together, let's store each student wherever memory is available. Student 1 2000, we will get a particular gap of what? 28 bits, because each value needs 28 bits. So here 28, here 28, right? Where we are getting the storage, we are selecting that area only, and in that area we are giving 28 bits to each. Here each node is defined of 28 bits, right? So here from this particular chart we can get this particular values, right? Now see, here we are also storing here, here, here and here. New problem. If we store students at different places, how do we connect them? Array, it is very difficult to connect, and definitely this is the problem which gave rise to particular data structure of linked list, where we are just connecting this particular address to this particular address of the value, 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 same until we get to the end. So we need the connection in between student records. So here each record must also keep the address of the next record, and here the linked list comes into play. Moving, node 1 will connect, will basically have what? Will basically have the data part and your, that is address part. Data part and your address part. Data part, here why it is null? Because it is the last node, right? If we are having the last node, it will definitely be equal to null, as because we are not wanting to connect the last node to anyone, because we don't have the value already to connect. So that is the reason why we are taking it as null. Here also you have different values, and here it will be equal to null. Here it will be node 3, right? It will not be 2. Yeah. So what is a node basically? This single unit which stores one student record and the address of next record is called a node, right? Stores a student record and the address of the next record is called a node. Value part, address part. A node is a structure that stores data of the student record and the address of the next node. We know two things: how nodes are created, how to establish connections in different nodes. So we have got this: nodes are created using struct student, where value part will be there and address part will be there. And how to establish connection in between the nodes? Via address connection. Now we need to create 5 nodes and connect them. Structure defined, making 5 values, roll number taken, we have taken the address. Now we are displaying the roll numbers, and then we are displaying the particular addresses. So now we will get the value of the nodes and also the addresses. Node, not value part, and the address part. And how you will display the nodes by iterating. Here you have defined the structure part, then we have also defined 5 values of struct student, roll number defined, we have connected the addresses. Now we will display what? We will display only the data part, that is temp of roll. And we are moving to the next, so that we could also get the next particular connected address value part, and that will be shown by using roll. Now display address data next pointers. What we will do, we will temp store the particular s1 value in temp, and if will not equal to null, until then we will print all these, that is address part, data part and next part. So here we have done this particular value and this particular value done. Now how to create nodes using malloc? We will particularly use the struct function first of all, and then we will create node. How you will create a node? Create a node by using the malloc function. It will create a memory block in C. In C we are coding, that is the reason why we have given malloc. And here the new node root role will be the value and address will be null, as we have created the first node over here, right? After creating the first node, we will connect the basically node to the previous node. Return new node, and we will display the list. Like here, if it is not null, display the particular address, data and next part of the particular value, right? Here we have defined all the structs, and here we have printed the loop also. New node we have created, and if it is not equal to null, head equal to new node, temp equal to head, else part temp of next equal to new node, temp equal to new node, display list, linked list will be display of head, return 0, that will give the head part only. Here we have given this particular values, right? So it will execute like this one. So this is a basic structure of how the linked list looks. Singly linked list is there, doubly linked list is there, circular linked list is there. It's a easy concept. I am making you understand in just 2 minutes. Singly linked list, head, next part, next part, next part, null. So it is just a simple value and address pair which we are wanting to see. Doubly linked list means we are having the previous address also, we are having the next address also, and we are also having the value part in the middle, right? So the null is present in the previous, head is the data part, that is the particular address of the data part, and next is the next node's address, and this is written in the particular way. And circular is just the last node, it's getting started from the first node only, that is the head part is coming in the first, and next the second part is coming, that is the second, and next value will keep point to its third value, that is 3, and in the next value we will point it to the 4, and after the 4 is done we will put the next address value part to the first node only. Here the circular linked list is clear. Applications by type of linked list. Here singly linked list is implemented using stack implementation, queue implementation, hash table chaining, adjacency list in graphs, polynomial representation. Doubly linked list. Doubly linked list we have browser history, undo, redo, as we are having what? We are having the previous part also and also the after part, that is the next part. So that is the reason why we can do undo, redo options, music video playlist navigation, LRU cache. LRU means least recently used. Text editor cursor movement, browser tabs navigation. What is circular linked list now? It schedules for round robin scheduling. That is, for this particular amount of time this process will work, for this particular amount of time this process will work. This is used using round robin. Traffic light signals, yeah, it can't be stopped, right? Either it will be red or orange or green. Green if shuts, red will on. If red shuts, orange will on. Orange shuts, green will on. Network token passing system. If a network passes token from one network to another, data packets are sent, and that token would be created in that particular packet only, and that is seen using circular linked list, as it goes the whole way around. Reverse of a singly linked list, we will just reverse the value pairs, that is all the cur next prev equal to cur, and cur equal to next. Head of prev will go to the value of return head, that is struct node star head in data. We will just reverse it of how we will place the value of new node to data and new next to null. If head equal to null, we will return the new node, otherwise we will place the value in the null part only. If we get the null part, then we stop at that moment only, and just reverse the list from left to right, we move from right to left, and then we will print the list. And here it's the main part of the particular program. Here we insert these values, original list we will give, and then we will get the reverse list, and this will be the output. Next is the implementation using linked list. A stack is a data structure that stores data in such a way that last inserted element is the first one to be removed. So here values will be used of applications of stack, function call management, expression evaluation, undo redo option, backtracking algorithm, browser history maintenance, memory management. Now how will you implement stack using linked list? A stack using a linked list is implemented by always inserting and deleting at the front head, that is the push operation. Insert an element at the top of the stack. Here it is the algorithm given. Now what will be the algorithm of this particular question? This is the algorithm, and you can note it down, and wait for a minute, like read it out loud so that I could also be easy to understand. So yeah, now as you have seen the algorithm properly, we will move to the particular questions. right? Now the pop operation is seen. Here we remove the top element from the stack, that is the pop operation itself, and the algorithm is given here only. What is the algorithm? You can read it out loud, or it is easy for you to understand. We start the algorithm, we check the top if it is equal to null. If it is yes, then we what do? We print the stack underflow like element is not present in the stack. If it is there, the element is present, then we create a temporary pointer temp, then we set that temp to top. Now store that particular temp data into a variable and we update the top to next, like top equal to top arrow next value you should take, and we will free the temp where we stored the top value, and here we will get the second highest value as the top value of a particular stack, and then we will return the value and stop. So how will you display the content of the particular stack? Yeah, so algorithm is to start first, check if top equal to null. If it is not, then move forward. Otherwise it is true, then stack is empty, like uh, right. So here we will set temp equal to top, repeat while temp not equal to null, print temp's data and move temp data to temp dot next and stop. So it will display the content operation from top to bottom, from the top to the last particular data of the stack. Now how will you implement stack using linked list? So where first we create the struct part, that is help us to creating the node. We will take the first node star value to be a null value, and then we push operation is performed on this particular value, so that the stack will be getting values, getting data. Here we create a memory allocation, then we check if new node equal to null, then we will printf stack overflow return. Assign data, new node data part will be equal to the value, new node next part will be equal to the top. That is what, that is the address particular.
Recording in progress.
Yeah, so new node next will be equal to the top only. So here it is very important for you to understand, as the next value will be the top. So top equal to new node, if therefore we have printed this particular value into the stack, that is what, the value part. Pop operation, we will need to remove the particular element from a stack. How will you remove? First of all, check if any element is present on the stack or not. If it is present, then we will set temp equal to top, then value equal to temp dot data, top equal to top dot next. We will free the temp that is storing the top value, and thus the top value will be erased. Pop operation and push operation can be performed at the top of the stack only. That is the reason why all the operations are being performed from the top of the stack only. And using the display operation, we will display all the elements present in the stack. If it is empty, it will show empty, otherwise it will print all the elements present in the particular stack. Now it is the function, like here it's easy for you to understand, as stack is not that hard. Now moving to queue. Queue is also a type of data structure where we put value in the data structure, and you can also get the value using the enqueue dequeue. Like we put the value from the start and we remove the value from backward, right? Enqueue means to get the value, insert at tail where it is present here. So we will start putting the value from here and we will start deleting the value from here, that is front. Dequeue. Enqueue operation means we are wanting to particularly insert the value, right? How will you insert? Using create new node. If new node equal to null, we will print overflow. New node data part value part will be equal, and new node data next will be set to null. That's the reason why if it will be null, then we set front equal to rear equal to new node, else rear of next equal to new node and rear equal to new node, it will be ended. Dequeue operation, check if queue is empty. If the queue front is null, then it will be empty and queue underflow will be printed. If the front node is present, we set the value of temp to front, right? Then we move front to the next node, where if front becomes null, then we will print the what? We will set rear to null, free the dequeued node using free temp. Now this is the code where queue implementation using linked list will be seen. Global pointer, struct defined, node structure defined in queue. Here we will just allow to give memory allocation to the new node. If we will check, it is queue underflow. If it is null, what? New node value, assign value, data value, and next value will be null, as it is the first node over here. If rear equal to null, front equal to rear equal to new node, it will be inserted, else rear of next equal to new node, rear equal to new node. Then enqueued, if dequeued means we want to delete the value, how it will be deleted, we move to the front, next, front equal to null, rear equal to null, free memory, free temp, display, we will display this particular thing using the particular code written in C. Main function is given here, we will print just the functions here in this main function to get the value, and here will be the output. Recapitulate the concept of recursion. Recursion means moving backward to get the particular function, and to use that function to calculate the values in the main function, and to get the value. It is a time taking process, so it will take some time to execute this particular question. Consider problem finding factorial of a number using recursion. Finding factorial of a number using recursion, we will use the values of a base case. If n equal to 0, n equal to 1, we will return 1. Recursive case, n into factorial n minus 1, that is n equal to 0. 0 minus 1 will be minus 1, so 0 value is 0. 1 if we take, it will be 1 only. 2 if we take, it will be what? 2 factorial equal to 2 only. 3 factorial, 3 into 2, 6. How it will be 3? 6, 3 into factorial of 3 minus 2. 3 minus 1, that is 2. Factorial of 2 is 2 only, so 3 into 2 will be 6. Into main num, we have defined 5, 120 will be the output. How? 5 into factorial of 4, that is 24. 24 into 5 will be 120. Right. 4 factorial value is 4 into 3 into 2, 6 for the 24. 24 into 5, 120. Reverse a single linked list using recursion. We use the value of node, then we move to the recursive function to reverse the linked list, and this will be used to particularly reverse the single linked list. First we create the value, then we reverse the list using this particular reverse head. Now we'll check palindrome linked list is present or not. First define the structure, then global pointer for left side, then recursive function, then right equal to null recurs to the end main function defined over here. Here we will insert the node at the end, therefore the values will be printed like that only, and we will return that it is not palindrome. So it was all about the video of particular linked list, stack implemented using linked list, queue implemented using linked list, and recursion. So I hope that you liked it. Give a thumbs up if you liked it, and yeah, and subscribe to this channel, particularly of full-on coding. We will be making leech code problems also, so stay tuned, right, and do support. Thank you so much for watching. See you in the next one. Bye.